Great job on solving those practice problems above. Now we're going to move on to a challenge problem, but it's really not that much challenging if you just take a minute to think about it. Given this trinomial as the area of a rectangle, find the perimeter. So there's a couple things we need to do. First, I hope you know that the area of a rectangle is length times width. To find the perimeter, we have to add the four sides together. So I have a rectangle. The area equals x squared plus 24x minus 81. So to find the dimensions, I need to know what did I multiply together? Well, I need to factor. I need two numbers that add to 24, but multiply to negative 81. I'm curious about that. I admit I had to pause the video because I thought for sure I had a typo, because off the top of my head, I am unaware of numbers that add to 24 but multiply to 81. So here we go. I'm going to make my list. If the sum is positive but the product is negative, I know one of them has to be negative and one of them has to be positive. The larger will be positive because my sum is positive, so that won't work. 2 does not go into 81. It's an odd number. Add those digits together. 3 goes in there. 3 goes into 8 twice. Oh, that is the factor I did not think of when I think of 81. Immediately I think of 9 and 9. But I add those together, I get 24. So that took a moment for me to pause. Here we go. So -3 and a positive 27. Meaning, and it doesn't matter how you label what side is what, one side, because it's length times width, will be x minus 3, while the other is x plus 27. So to find the perimeter, I need to have 2 of those. So I'll have x plus 27 plus x plus 27. And I need to have 2 of those. And this is really going to become combining like terms. So I have 1, 2, 3, 4 x's in all. Then I need to add my, constants. So I have 27 plus 27 is 54. Minus 3 is 51. Minus 3 is 48. So the perimeter is 4x plus 48. Phew, just had to think about it, but we ended up using factoring and adding polynomials that we learned earlier. Okay, now we're actually going to solve. Remember when I talked about solving, it is finding the x-intercepts, also known as the roots. This exponent tells me how many solutions I should have. These are parabolas. They will have 2 x-intercepts. First thing you need to do is factor. Just like before, I am looking for numbers that add to 17 but multiply to 52. Well, that's even, and I mean not even, that's positive and that one's positive, so 1 times 52, that won't work. Even number 2 goes in there 26 times. When I add those together, that's not enough. 3 goes in there, nope. 4 goes in there 13 times. Ooh, not a multiple I would have thought of. Plus 4 plus 13. So x plus 4 times x plus 13 still equals 0. Just like in the past, you're going to take each term, Set it equal to 0 and solve. Subtract 4 from both sides. Subtract 13 from both sides. If I was to graph this, I would have an x-intercept of x equals -4 and x equals -13, and the parabola would look something like that. On the next one, again, we're going to factor. I need numbers with a sum of -18, but a product of +80. Because the product is positive, but the sum is negative, I know I'll be multiplying two negatives together. Well, that doesn't work. That does not work. 3 does not go in there. -4 times -20. 5 goes in there 16 times. That does not work. 6 does not go in there. 7 does not go in there. Ooh, -8 and -10. Add those together, I get -18. Multiply, I get +80. So x minus 8 times x minus 10 equals 0. Set each of the factors equal to 0 so I can find the x-intercepts. One x-intercepts at +8, the other is at 10.